All right, so we talked about this yesterday, right? We started talking about inverse operations yesterday. We didn't stamp it. I told you yesterday that I wanted to make sure we stamped it today, so that's what we're going to do. Because today, if you look at our header, we're now starting multi-step equations. And so gone are sort of the days where we're just going to do one step and it's completely done for us. Moving forward, we just got to do a little bit more. And so first is inverse operations. And so inverse operations are operations that undo each other. Operations that undo each other. Now, we actually wrote in our key takeaways yesterday the two pairs that we have, or well, the two pairs that we're going to work with. And so the first one is addition and subtraction. And then the second, multiplication and division. If we see subtraction, we use addition. If we see multiplication, we got to use division. Based on our work yesterday, we're in a good spot of recognizing what to use, and even this morning, recognizing exactly what we got to use to cancel out. This is all we're putting on the front. As soon as you have this, put pencils down so that I can see. There. This column, very fast. Thank you. A few of us still writing. That's okay. Take about 10 more seconds. Make sure we got this. All right. Flip your notes. So, for example 1, we want to solve for x. Now, the first note here that I'm going to make is what we talked about yesterday. Again, I want it to live in our notebook. If we see solve for x, my goal then is to isolate x. That's what I'm really trying to do. I need it alone. I need x equals whatever the number is going to be. And so in order to start this, I actually want to make an annotation that we saw last week. I'm going to annotate my order of operations. Because I'm hoping we notice something interesting happens when we're using inverse operations. Okay, I have 3x plus 5 is equal to 10. I know that I need x fully alone, and so I essentially have to start peeling back the layers of the side that x is on. And so raise your hand. What do you think the first thing I have to deal with is? Gabby. I'm going to subtract 5 on both sides because the plus 5 I have to deal with first. Okay, so minus 5, minus 5. On the left, the 5's cancel. Good, that's what we want. I'm going to have 3x is equal to, and then everybody, 10 minus 5 is 5. Make sure we have 5, and that we're not purposefully shouting the wrong answer. So, okay, 3x equals 5. Now, from here, and listen to the question carefully, raise your hand. What is the operation that we have in our problem? What is the operation that we have in our problem? Gabby. Ooh, careful. Do we see division right now? Okay. We see multiplication. We see multiplication. 3x is, like we saw yesterday, implied multiplication right here. Yes, there's no actual sign saying 3 times x. There's no small x. There's no dot. There's nothing like that. However, two things next to each other we got to know means multiplication. And so now, we've already had a sneak preview. Raise your hand. What operation do I use to undo multiplication? What operation do I use to undo multiplication? Eden. Louder. Louder. Division. More specifically, raise your hand. I'm going to divide by what number? Janaya. 3. Going to push this one more time. Raise your hand. Why do I divide by 3? Gabby. To isolate x. And so specifically, 3 is our what? Raise your hand. What is the vocab word for what 3 is right now? Gabby? Close. It's not quite a variable. It's the thing next to the variable which gets a really special name. Charles?
Coefficient.
Louder.
Coefficient.
Louder.
Coefficient.
It's a coefficient. And so anytime we see multiplication like this that we have to divide by, you always divide by the coefficient. And so everybody, you always divide by the coefficient. Okay. We're gonna do a lot of that. So here, 3's cancel. Good. That's what we want. And so now instead of 3x, I have just the singular x is equal to 5/3. Now, not a great fraction. However, there's nothing we can do to reduce it. Answer lives like that. And so now, before we move away from this example, I want you to think about the steps that we took and how they relate to the order of operations. What do you notice about how we had to work through our order of operations? What do you notice about how we had to work through our order of operations? Turn and talk. 30 seconds. Go. Far side talking. Thank you. We're there. We're there. Start and turn talk. Thank you. We're there. We're there. Yeah, it's on that side of the room. All right, everyone bring back, please. In 3, and in 2, and we're all the way back. In 1, please. And thank you for there. Jeremiah, thank you. Aria, we are there. We're there. Jose, thank you. Keith, Janaya, Paolo, just make sure I get eyes. Shamik, same thing. Eyes, please. Charles, thank you. We're there. All right. I will take a volunteer here. What do we notice about our order of operations when we use inverse operations? In. Yeah, and so I'm gonna really clue into the first part you said, right? What was the first operation we used? Subtraction. Everybody, what was the second one we used? Division. Is that our normal order of operations? No. And so what do you notice about the fact that we do subtraction and then division? We know it's not the normal order of operations, but I'll say even more specifically, what way are we going through them? I heard it. Say it again. Who just said it? Janaya, louder. Louder. Backwards. When we use inverse operations, we go through these backwards. And so, yeah, I start with subtraction. If this was subtraction, I would have started with addition. And then I move to division in this case. But again, if this was division, right, if it was x over 3, I would have used multiplication. And so down below, I want us to stamp that in our key takeaway box. When using inverse operations, we work through GEMDAS backwards. When we use our inverse operations, we work through this backwards. And so instead of going down the list, we go up the list. Where are our notes? Yeah, so we're on notes is what I'm saying to you. All right, take about 10 more seconds to get this down, and then we're going to look at example 2 and just finish out notes all together. All right, so example 2, solve for x. Now, again, yeah, we need to isolate. Again, I'm going to put my order of operations here. Going to remember that with inverse, I actually need to go bottom to top there. And now, when I look at this, 3 times x plus 4 equals 10, raise your hand. What is this scream that we have to do first? Gabby. Multiply. Be more specific. What kind of multiplication? You're not wrong. What do we call it when we multiply like this? Aiden. Ooh, careful. Not quite by grouping. Not quite by grouping. Shamir. Louder. Distribute. Louder. Distribute. One more time. Distribute. Yes, we got to distribute. And so we're going to take this 3, distribute it to the x and to the 4. And so to Gabby's point, yeah, this is just multiplication at heart, just a special type. And so we're going to have 3x plus everybody. 3 times 4 is, there it is, equals 10. Now, I'm going to start using inverse operations. And so now we're going to go backwards through this. I see that I have addition. Raise your hand. How do I undo addition? Eden? Louder. Subtraction. Minus 12 on both sides. I actually want a raised hand for this. What is 10 minus 12, Carol? Negative 2. Make sure we got that negative. From here, I see multiplication. So just like we saw, I'm going to use division. Divide both sides by 3. Because 3 is the what, everybody? Yes, again, 3 is the? Okay. And so, we're going to be left with x is equal to negative 2/3. Again, this is our final answer. Cannot simplify that in any way.